What is up, everybody? Alright, so this is Austin with Chronotide. I'm bringing you a video in Minecraft. We are on a redstone test area. Excuse me if you can't hear me too well. It's pretty late at night and I'm pretty tired, but I will try to make this as quick as possible and as easy to understand as possible. So I was watching a video on Ethos's YouTube channel, and he was talking about doors that he made inside his little in his laboratory, in his underground system that he has on the CrackPack server. The setup he was using was something like this. He was using a proximity detector, which is from ICBM, connected to some redstone that was inverted and then ran into some drawbridges, which opened. And it worked. It was pretty nice. I personally didn't really like it because you can't really control it too well. You can control it as players or mobs that control it, and how big to control it. But it requires power, and it really just doesn't do everything that you would want it to do. So I just wrote something using the ComputerCraft mod, which is a part of the CrackPack stock. You know, it's not something extra. And it's just something that I really like to use, and I know that Ethos used it before in the past, so he does know about it, which is good because starting out in it is not the most fun. So let's go ahead and take a look at it. It's not running right now, which is why the things are up, but let's look at what we have first. We have 3 pieces of redstone, something called a sensor, which, as it says right there, is from Open Peripherals. It's an add-on to Open Peripherals, and yeah, that's pretty easy to make. Let's look at how you make one of those. 3 obsidian, a stick, and 3 slabs of your choice. And then I have an advanced computer. You do not need an advanced computer, but I just wanted one. It looks nicer, more nice, prettier thing. That takes 7 gold, a redstone, and a glass pane. A regular computer, which you can do this with, only costs 7 stone, some redstone, and 1 glass pane. So let's look at what I actually have done. First I'll show it working, so just run test, enter, and nothing's happening. But if we run far away, you will notice that the doors came down. And then if we run close up to it, all of a sudden, hopefully, it opens. And then if we stay here, it won't close, nothing will happen. We can stay under here, we can do whatever we wanted under here, it won't matter. And then as soon as we leave and get out of the range of the sensor, it closes again. Alright, so now I'm going to show you exactly what goes on behind the scenes. I'll try to make it as quick as possible. So let's go ahead and get started. I will talk about this in 1 second. But let's go ahead and reboot the computer, and let's edit. Edit test. Alright, so this is everything we have. It's not too long. It's actually pretty short for any sort of ComputerCraft code. So let's take it line by line. P equals peripheral.wrap. What this does is it sets up that anything that you use as the variable P will be peripheral.wrap_right, which is the sensor. So every time you type P and use it as a variable, it will call upon this to run whatever you're asking it to do. Next, I set up a function, which we can look at in 1 second. Let's go down here first. So we have while true do, which means that it will be a constant loop. Typically, if you do any other command, once you get to the end of it, it will either end the program or go on to the next step. While true do basically means that it will constantly cycle through everything that you do, and it just won't stop. If you have it set up to where on startup the computer will run the program, it will constantly just do this, even if the server gets reset. And to do something like that, all you'd have to do is go edit startup, and then type in shell.run test, I believe. So now if we reboot this, it is running test, and we should see that this is working. Hopefully, I did not just lie. Yep, there we go. Alright, so just type shell.run and then in. Let's go ahead and terminate this. So I'm going to go ahead and edit starter because I want to be able to reboot. So just go ahead and do that. You can name this whatever you want. You don't have to name it test. You can name it open doors or whatever you want. So let's go ahead and delete all this. Save, exit, and edit test. So where were we? We were down here. So right here we have players equals p.get player name. So this is where that setting p to that peripheral works. So we're using p as a variable, so it's calling on the sensor to get player names. Alright, and it's setting that as players, which is also kind of like setting another variable. So now every time it sees player, it will know to call back to p.get player names. And then we have redstone set output back true. So what that's going to do is at the beginning of every time it comes back to this step, it's going to make sure that the redstone on the back is turned on. Ooh, got a little bit of lag right there. Come on. Ooh, seriously going down right now, guys. Alright, let's go back here. Then we have forward. Okay, so this is where the actual commands start coming in. What this is doing right here is it's calling the table that this set up. The way that ComputerCraft writes code is it uses a program called Lua, and what's nifty about that is that it uses a bunch of different types of coding techniques. It uses the Boolean, tables, strings, numerics. It can do simple math, like if you have it add 1, subtract 1, multiply, divide, it can do all that. So what this does is it takes it down and takes this table and then it kind of characterizes it. Like if you were to say print players without having this right here, it would give you a string, it would give you a table. But this puts it down into words that we will be able to use. And then I have written down that if the name is equal to my name, then it will run the function up above. So let's go look at that. So the function I have written up above is called open door, and that is to set the output in the back to false, and then it will sleep for 5 seconds, and then it will run the same thing that's run down here. It will establish if players is p.get player names, which I could just do that up here, but I didn't think about that until now. So if you really wanted to clean this up, then you could add that above the function, and then for everything below it, it will refer to this for players. And then if the name is me again, it will sleep for another 5 seconds. But if it isn't, if it isn't, then it will return the redstone output to true, and then it just goes through that, and that's the end of the function. At the end of the function, we have the computer sleep for 5 more seconds, and then it will end. It will print down the name, and then it all ends. So let's go back and we can look at all this work. So it will go through, it will set up everything, and then since it sees me, it will wait 5 seconds, or I guess at the end it's a total of 10 seconds. But what I did forget to do was I forgot to set it up to where even if it's in this stage, it will print the name. So we go. Alright, there we go. I think that is it. Yeah. Save, exit. Alright, so now it will keep on saying my name even when I'm here, hopefully. Yep, there we go. Alright. So what I like about this, a couple things different than that, is this gives you a full log on who has come in and who has come out. It doesn't necessarily tell you which direction they go, but it does let you know where people have been. and even if they're not on the whitelist of people to get in, if they are excluded from the list of people, it will still display them. Because if this is not set up, it will still continue with this, and it will print down who's there. And it's also very easy to configure. If you want to add another person, you just don't do that. You put your cursor right here. You just draw out this. Let's go with who is a person, and then you add another one. Add a space. Press or and space. So this will do is it will look for a person with the name of DIF or a colon. You can continue this as long as you want. You can there, go like this, type in another name, add another one of this, add an or and a space, and then of course if you save it and you exit it, run test, it will still work for Austin, or for a colon. It will still print it, it will still open the door for me, it will still close the door as soon as it's far away, so adding a name in front of it, as long as you put the or, will not cancel out the rest of the code. So yeah guys, I think that's it. That's really all I had to show. I just had to show an idea that I had to use instead of the proximity detector, because you'd just be able to configure it. Now of course if someone's going to break into your base, you know, that's really not going to stop them. It's a lot cooler. It's a lot more fun to show people. There's a lot of customization you can do with this. I've seen codes like this where people have put in security codes and then had a actual rednet upload where all your security was not on the actual computer. It was on a main computer, and then you had a computer with each sensor underneath each door that would call to the computer and find out exactly what each security door, what the level was, which was stored locally, and then you would find out from the master computer what security level this certain person had. And that was really nifty, but I don't really think you need that at the moment unless you want to really want to separate your base. Like say you have a main hub and you want to control the door to get into the main hub, but then control the different doors to get into other people's sections. You could set up a system like that, where each door was labeled with a certain number, and then one door had any number to go through, or certain numbers go through. But yeah guys, that's going to be the end of this video. I hope you guys enjoyed it, and I will see you guys next time.